Okay. All right, so I think we're off and running here. Okay, so like I said, my name's Mickey Burke, and we are going to be talking about living and learning with Parkinson's disease. And let me try this. Is that working? No. Sorry, let me try. Okay, there we go. Now I think we're working. Okay, so as Callie mentioned, I live in San Diego, and I've worked with individuals with Parkinson's disease for about 10 years. I have my very first initial exposure to Parkinson's disease was with my opa, or my grandfather, in German, and he had Parkinson's disease. That was a little, I was a little too young to really know exactly what was going on. But then Parkinson's disease kind of popped up again in my life when I was at UC San Diego, getting my undergraduate degree, and I worked in a neuropsychology laboratory. And that's really where I got this kind of overall gross fascination with the brain, and all the things that can go right with it and all the things that can go not so right with it, Parkinson's included. So I've gotten to really be fascinated for the last 10 years on all this just wonderful, interesting, fascinating stuff. So the last few years, I've created this company, and I'm striving to combine that cognition, which was my very initial exposure to Parkinson's, and movement, and making this a kind of one-stop shop for improving the quality of life for individuals with Parkinson's disease. So as you can see on the screen, that's my mission statement. And you can go ahead and just follow along. Today, what we're going to go over, as I mentioned, is just a very, very brief overview of the brain. So what's really going on, just on a very kind of global scale. We're going to go over the different areas of the brain and what is responsible for those particular areas and what can go on during disease states and otherwise. And then in particular, we'll talk about Parkinson's and cognition. And then ultimately, what we can do about it. So this is something that I think is extremely important, is what you can glean from this talk, what you can take with you, put in your pocket, and really do to change your life. Okay, so this is just a little cartoon of the brain, and we're going to go over those different aspects briefly. So this first area, it's colored red there. It's the frontal lobe, and that's just in the front part of your brain and the front part of your head. So your eyes kind of run down just below that. But the frontal lobe has these kind of functions, if you will. So parts of everyday life where we need to plan or problem solve, you have to decide what you're having for dinner, even how we move, that motor cortex, that's all found in that very frontal part of the brain called the frontal lobes. Just behind that are your parietal lobes, and there that's kind of outlined in that yellow color. Here we can see things where our sensations are called upon, and our language as well. Further back toward the back of the brain in blue, there's your what's called your occipital lobe, and that's where our vision is called upon. So that area of the brain is involved when we see things and comprehend things when we see them. And then finally, we have our temporal lobe. So that's in purple, kind of down at the bottom there in the middle. And here, these functions can include our language, how we hear, and there's a structure deep in the temporal lobe called your hippocampus, and that's involved in our memory. Now, how do I know that? How do we know that? How do people know that? So there's this field called neuroscience, and that is the study of the brain. And within those kind of umbrella term of neuroscience, there's a field called neuropsychology. And again, that's that laboratory that I worked in, and I was initially exposed to this field. So I'm going to take some time here to go over what exactly neuropsychology is. There we go. So neuropsychology can be divided into these 5 cognitive domains. So there might be a little bit of a mouthful, some big words, but those are basically different categories of cognition. So when people hear cognition, they might automatically think thinking or memory, but that's not all that goes into it. So those 5 cognitive domains you can read on the screen there. We have our attention and working memory, our executive function, our language, memory, and our visual spatial comprehension. So here, as I've kind of combined the last few slides, here we can see that the different areas of the brain, those frontal lobes, parietal lobes, occipital lobes, temporal lobes, they have those different functions. And again, this is just a kind of a repeat of that slide. But now we can add in those cognitive domains. So what you can really glean from this is that within the brain, there are specific areas that are responsible for specific tasks. So that frontal lobe, we have that attention, we have that working memory, we have executive function. In the parietal lobe, we have that language comprehension. The occipital lobe, we have that visual spatial cognition. Temporal lobe, that language and memory. So you might see some overlap here. And that's something that we'll certainly talk about more and more today, is that the brain is very plastic and it can cross-talk. So multiple areas of the brain can be involved depending on the demand of that particular task. So let's go into a bit more detail here regarding those specific cognitive domains. So that first one is working memory and attention. So what do we mean by that? So as I said before, it's kind of holding things in your memory as you multitask or do something else. So a digit span, for example, letter number sequencing, naming of words, processing speed. So within the neuropsychology field, there's different tests. Many of you perhaps have gone through a neuropsych evaluation and have perhaps even done a lot of these tests. Now, what we're going to do is a little example. So if you can see on the screen, and unfortunately with Zoom and everything, I'm going to have to take your word for it that you are actively participating there. But you can kind of see at the top right hand of the screen, there's those 2 lists of words, and those are colors. So what I'd like you to do is to initially read those colors. So just say those words. You can read them out loud. Okay, so it's green, yellow, red, blue, yellow, green, red, blue, green, blue. So now what we can do in this color word interference test or Stroop test, that's one of those neuropsych tests. This is what we initially give you, is that first most basic kind of bottom level, just read these words. Okay, so next what we'll do is make it a little bit more challenging. Okay, so right here, what I'd like you to now do is just to name the colors. So that yellow block there, you would just say yellow, green, red, blue, green, yellow, blue, red. Okay, not so bad. However, when we scale it up a bit more and make it a bit more difficult, a bit more challenging, what we can do now is to have you read the word but ignore the color. So that very first word says blue. However, it is printed in that green ink. Okay, so just by nature of that, we are having to hold in our working memory this rule or this task to ignore what the color is but just read the word. So we're having to attend to that, okay? So that in example, in a kind of brief term, is our working memory and attention. So that's one of those 5 cognitive domains. So let's move on to what's called executive functioning. So again, if you can remember from a few slides back, that again is that frontal lobe. So that executive functioning is called upon from this area of the brain in the very front. Now, this is where we can, as humans, we can plan. We can really try to almost multitask. We can ignore things. We can plan. If I were to ask you a certain letter of the alphabet, a certain category, very similar, as I mentioned from the previous cognitive domain, that working memory attention, we can interfere with that color and word. And then let's go into a few examples from that neuropsychology field. So again, here, I'm gonna have to take your word for it that you guys are actively participating out there. So on the right-hand side, I'm gonna ask you to say as many words that you can think of that begin with that letter B. So in neuropsych, I would give you about 60 seconds and I would record every word you were to say that starts with that letter, okay? So take some time, shout it out loud. Again, I wanna try and hear you and take your word for it that you guys are actively participating out there, but really try to challenge yourself and say as many words that you can think of that begin with the letter B. Okay, so hopefully I'm not seeing too many eye rolls out there or anything like that, and you guys are actually going for it and trying here. So let's move on and make it a little bit more focused. So if I were to give you a little bit more of a category, if I were to ask you to imagine yourself in a supermarket and then ask you to say things that you could find in the supermarket. So it's no longer the letter B. You don't have that stipulation to stay within that letter to start, but now it's switched. So now something in the supermarket, anything that you could find in the supermarket, go ahead and say as many things that you could find. Okay, that's about a good enough time. And then what we can further do, this is gonna switch for me here. So what we can further do is make it a bit more difficult. So make it a little bit more challenging. Sorry, guys. Okay, there we go. So again, this is becoming a bit more challenging within that cognitive domain of the executive functioning. So if I were to ask you to first name a piece of furniture, any piece of furniture you want, could be a couch, could be a chair, could be an armoire, something like that. But then I'm going to have you switch and say a piece of fruit. Okay, so this task is now asking you to name one of 2 categories and having you switch between those 2 categories. So again, this is a very demanding process for the brain from that executive function standpoint. Okay, all right. So moving on to our third domain of cognition, it's language. Now, language, as I'm sure everyone can attest, is something that can be difficult in Parkinson's disease. A lot of people might say they're having some issues with that kind of tip of the tongue syndrome, if you will. So you're having trouble naming something or remembering someone's name. Or it's like, oh, who's this? Or telling a story. It's I just can't remember. So that's your language. Okay. And one of the ways that we can test that in the neuropsych world is with what's called the Boston naming test. So this is a test where I've provided this picture for you, and it's up to you to tell me what it is. So we all know that that looks like a pretty cool wheelchair, right? Next, I could give you this picture. Now, this might be something that is a little foreign to people that perhaps live in warm climates such as Arizona and Southern California, but that's an igloo, right? So This test is scaled up. It gets a little bit more difficult as the test goes on, giving individuals a visual stimulus that might be a little bit difficult or less common. So calling upon that language or retrieving that word that has not been in your vocabulary for perhaps many years, okay? So what we can do from this is kind of collect these scores and give people an average, a result on tests like this. So in language, how I can score this is give you full credit if you were just to outright name igloo. However, if this couldn't quite be, you couldn't quite retrieve that word, you couldn't quite spout it out, I could then give you a little help. I could give you a little hint or a cue and start to say, well, this is something that might be found somewhere cold or somewhere that people live where it's cold. So kind of giving you a little bit of a hint that kind of might focus that answer a bit more. If you still can't quite retrieve that word, I then would give you what's called a phonemic cue, and I would start to pronounce the word. So I could say ig, 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 and that can spark almost that word finding to happen. Oh yeah, igloo, of course. Okay. So moving on to that fourth now cognitive domain is memory. So again, this is probably something that quite many of you are familiar with as far as cognition is memory. Now, memory is pretty vast from the neuropsychological standpoint. There can be a visual memory, there can be an auditory memory, there can be a recall issue. So again, many smart people devote their entire careers just to focusing on these little aspects. And again, unfortunately, I just don't have the time to go really in depth with all of this information or deep into this field. But again, this is just to give you guys a kind of a brief overview of those cognitive domains. So let's go into some examples here. So again, if I were to have you sit down in a lab and we would go through this memory test, what I would give you is out loud, I would say this list of words to you. So I would say lion, emerald, horse, tent, so on and so forth. And I would present that to you a few different times. Hopefully, ideally, a properly functioning, a healthy brain would be able to encode those words and commit them into their working memory. Okay. As time goes on, I could ask you to immediately recall them. So after the 2 or 3 times that I mentioned that list of words, I would ask you fairly immediately to recall as many of them as you could. Then I could wait about 20 minutes and give you what's called a delayed recall and ask you, hey, you remember those words that I said to you a while back? Can you say any of them? Now, a lot of people might have some difficulty with that. Oh, shoot, well, it's been too long. I can't remember those. Not to fret. With this kind of cognition, there's, again, different kind of cues that we can do to get you there, okay? So for example, with this in particular test, at the very end, I'm almost giving you a recognition recall. So if I were to say horse, did I say horse? Yes or no? You're given that choice. You can recognize it. Okay. So I'm no longer asking you out of the blue to recall those words. I'm presenting a word and I'm giving you a choice. So that, as far as a memory standpoint, is a little bit easier, quote unquote, to retrieve than something that is just a free recall. Okay. All right. So the final domain of cognition is what's called our visual spatial cognition. Now, this is a big one. I think arguably between this one and the executive function in Parkinson's disease, these two I would think are challenged. They are typically difficult for an individual with Parkinson's disease. So that visual spatial, it might, if you break down that word, it's pretty intuitive. So it's your kind of visual perception of where you are in space. Okay. So this skill is called upon a lot, pretty much every time our eyes are open, right? When we walk, when we are driving, these are huge aspects of our daily life. Okay. Now, how do we test this? How do we know if someone is functioning at that level where they are similar to others? If they are in that age range, if they're in that educational level, if they're functioning as someone close to their peers, right? This is a test where we can figure that out. So this little presentation here, you can see it's kind of this fanned out halfway, half circle here with these lines. And those lines are numbered 1 through, I believe, 11. Now, what you can do on the top here is there's just portions of these lines that have been erased. Now, your job as the person being tested is to tell me which 2 numbers are represented by these 2 portions of the lines. So it's 6, right? So that's perfectly vertical up and down. So that's 6, that makes sense. But then what about this one? This one's a little, throws kind of a wrench into things, okay? So it's certainly not 5, that angle's too sharp. Probably not 4, could be 3, right? I'm thinking it's 3. Okay, all right. So overall, we've gone over those 5 cognitive domains. Now, this is something that is, it's kind of a combination, universal cognition or global cognition. Now, this particular test is the MOCA, and many of you, for my friends and clients here in San Diego, you know I've given this to you, okay? For those of you that are unfamiliar, this is the MOCA, the Montreal Cognitive Assessment. So this is a very brief overview of global cognition. This is something that can be done in the clinic. This can be done something in the neurology office with your doctor. But this is a very kind of basic level of what's going on for your cognition, okay? Now you can see, I put just a little screenshot of the actual exam there, but it goes over those many of the cognitive domains that we just went over, okay? So again, this is something that I collect on pretty much everyone that I see here. One of the things that I really like to do is to time this. So from start to finish, how long does this completing this entire test take an individual? Now, and everyone's a little bit different, as you guys know, but typically, typically this can take anywhere from 10 to 15 minutes. So it's just a brief, pretty quick cognitive screening tool, okay? But what I'm interested in is seeing how fast this takes you and then testing you over time to see if anything can be sped up. If you can complete this task, if you complete this test in faster manner, okay? So that's something that we'll touch on a little bit later, going through things quicker, okay? All right, so that's as I said, a very kind of brief overview. Gosh, I've been talking about half an hour, so I need to step on it. So how do we know what's going on? We went over what neuropsychology is, but there's also this field within neuroscience called functional MRI or fMRI. So it's in that big scanner. It's a big magnet. What you guys can see here is you're put in this scanner and you're given some sort of stimulus. You're able to see something. There's usually some screen inside the machine that's basically measuring the blood flow. So what we can glean, what we understand from this is that when you are presented with a particular type of stimuli in that scanner, different areas of your brain will light up. More blood will go to that area when that particular stimulus falls under those cognitive domains, okay? So to me, I think that's the coolest thing. So while you're still alive, or we're not opening up your brain, we're not looking to see what's going on through doing some paper pencil tests and putting you in a scanner, we can tell what's going on in your brain. I just think that's fascinating, okay? So if you can take one thing away from that is we can tell that there's different areas of the brain, and those different areas of the brain are used for different tasks, okay? So let's stop, let's take a moment. Basically, I said this already, but we can know that those brain areas are diverse, and that they are called upon for those diverse um, domains or different tasks, okay? All right, so now let's go ahead and switch gears a bit. What's going on in Parkinson's disease? So we should all be quite familiar with what's going on in this disease. First off, it's a some sort of issue with dopamine. And we are sure that it's something that can come about when a portion of your brain called your substantia nigra stops producing those dopamine producing cells. So typically about 50%, anywhere from 50 to 80%, I think I've read that dopamine is depleted before those motor symptoms show up. So remember that, and we'll kind of circle back to that a little bit later. So not only is dopamine not produced as well, but it's not communicated as well. So between the cells, between those brain structures, within those circuits, there's not enough dopamine, and the dopamine that is there isn't working as well as it could be. Okay, so that's what we know, that what's going on, and it can present in this motor standpoint and also this non-motor standpoint. So many of you know all about all of this, right? You don't need me to tell you that you might feel slow when you move. You might feel rigid or stiff. You might have that resting tremor. You might have gait balance issues. Your posture might be a little stooped, okay? Those non-motor components can, or dopamine can have those non-motor components affected. So in particular, that cognition, the mood, depression, apathy, anxiety, sleep can be affected, constipation can be affected. So things like that, we're really discovering more and more that it's not simply not just a movement disorder. So what can we do about it? Well, there's medication, and that's optimal. We need that. We need to have some sort of dopamine replacement to go back into the system. And then of course, exercise. So you guys know this, the power moves, those are foundational. I don't need to tell you guys about that and the importance of exercise. So as I kind of alluded to earlier, and this is a bit of a busy slide, but what we are concerned with is the communication within the brain. So that dopamine, in addition to having those Parkinsonian functions affected, it has a communication between different circuits. So this slide, this cartoon can show you that the basal ganglia, that kind of big middle part there, that's where that substantia nigra is. And those circuits go into the front of the brain and up into that motor pathway up at the top of the brain. Those can be affected by dopamine. So they can be, there's some sort of miscommunication, there's some sort of problem, there's misfiring between those circuits, okay, with Parkinson's disease. So let's go into some Parkinson's disease cognition, and hopefully this slide will stay there. One of the big aspects, one of the biggest complaints that individuals have with Parkinson's disease is that cognition. So one of those non-motor symptoms. Now, the more we learn about cognition, sorry, my computer's being really slow, guys. Okay, so as I was saying, in cognition, there's what's called your normal for aging. So as I mentioned before within neuropsychology, we can take those results that you have on each of those tests and compare them to individuals that are your same age, your same gender, that have your same amount of education. Now, if you perform well or average to those people, that might be considered what's called normal cognition. We're all familiar with dementia, and at least the term, and that is something that you perform, it can be diagnosed when you perform below average on those areas of cognition, those neuropsychological tests. However, there's this mid-range, so it's not quite dementia, it's not quite normal aging, it's this mild cognitive impairment. And typically what we're seeing with Parkinson's disease being a degenerative disease over time is cognition can change throughout the disease progression. So again, this is something that we need to review. It's this neuropsychology, those cognitive domains, there's those 5 domains. Again, that MOCA, this is a brief kind of global test that I do with my business, but it's basically between these 2 neuropsychological options, we can glean and almost diagnose someone's cognition. So specifically, the Movement Disorder Society, so this is a group of experts throughout the entire world that focus on Parkinson's disease specifically and other movement disorders. So these are doctors, these are researchers, these are experts in the field, and in my book, they are gold standard. They've created this task force and differentiated what actually constitutes a mild cognitive impairment diagnosis. So you can see here that MOCA, we can have that abbreviated assessment. If you, depending on how you score, we can decide, we can use that term of mild cognitive impairment. In addition, if we have that whole neuropsych battery, so tests within each of those cognitive domains, that can be several hours worth. You sit down with an individual, run through all of those tests, and you're given these scores. If we find that there are deficits or you perform a little bit lower than the average, that is indicative of one of these 2 levels of mild cognitive impairment. So you can see level 1 and level 2. Level 1 is just a bit more surface level, it's abbreviated. Level 2 is much more extensive. So that's the one where you're sitting down, you're going through that entire neuropsychological battery. And at the end of the day, if you have deficits in 2 of those, or you score below average in 2 of those areas of cognition, that's indicative of a mild cognitive impairment. Okay, so what can we do about it? Well, we know that through different, we know that we can slow the progression of cognitive decline. We know that if we are able to detect that cognition, that certain level at one point in time, we can therefore take that information and plan ahead. Several studies have shown that through different types of therapies, cognition can be restored and actually go back to a normal cognitive level. So how do we do that? And it's exercise, gang. So this is something that I know the Power Gym is screaming from the mountaintops. I really try and scream it from the mountaintops in my classes and with my clients and friends. But this is something that we know works, guys. This works. So let's go into a bit more about what we can do about preserving that cognition. So we mentioned exercise. So exercise is aerobic, right? So what we think of in the more traditional sense of exercise can be aerobic, where you're dripping sweat, where you're huffing and puffing, your heart's beating out of your chest. That's great. We want that. That's good. Okay. What we can see from different research studies a few years back, a big time group out of USC in Southern California, they showed that in humans with early stage Parkinson's disease were on a treadmill and they exercised. And it showed that they're within the brain, they can take and receive dopamine better just by exercising, okay? Which is fascinating. That's wonderful. In addition, there's research out that just by exercising moderately, with moderate intensity of that aerobic exercise 2 to 3 times a week, can lead to some improvement in executive function as well as language, okay? Now, there's another area, and what we're really discovering more and more about is this area of skill-based exercise. So it's not simply the huffing and puffing and you're dripping sweat, but it's an engaged, cognitively engaged exercise. So it's almost like a brain exercise. So anything that you can think of that is challenging, that is new, that is different, that's skill. You're requiring that area of your brain. It's skill. You're trying to learn something, okay? That brings me to my next point of this motor learning. So this is a very kind of basic concept. We've all done it. We learn to crawl, we learn to walk. This is motor learning, okay? But what we can find is that when we, as humans, when we learn things with our body, we learn how to move our body, that is almost more so cognitively engaging than doing a cognitive task. So for example, sitting down reading a book is somewhat cognitively engaging. However, learning how to play tennis is much more cognitively engaging than reading a book, okay? Like you can tell I'm getting excited than talking real fast, but this is it just so neat to me. I find it fascinating that when we learn something and we incorporate different parts of our body and different parts of our brain, it's just such an engaging process. And what we've known from past research is that when we learn a motor task, it's beneficial to have some sort of motivation. If we are with others, if there's some social stimulation, if we can see, if there's some competition, if you can see someone else doing a plank for longer than you, that's going to give you some more motivation to do better, right? If you can have some sort of internal motivation, if you have, well, you know, I find this interesting, I kind of like it, but if there's some sort of vital essence. So if you guys remember back from the 80s, there was this kind of goofy movie called Dark Crystal or something, but this guy says, what's your vital essence? What gets you up out of bed in the morning? What are you doing this for? Why are you here? If you have an answer for that, if it's picking your kids up or picking up your grandkids from the floor, if it's getting up and down from the floor, if it's being able to walk when you're 70, okay? Whatever goal you have, if you believe that, if you have that in your mind, that's gonna make your brain more receptive to learning, okay? And that, I just love that. That final point, this big word, this generalizability. So that's basically taking a component of a motor task and applying it to the sum of its parts, right? So let me take a step back. If I want to learn how to throw a football, or if I want to be a quarterback, yeah, I can throw the football with my dad in the backyard, but I'm not going to get good at it until I'm actually in a game. And if I'm put into that kind of almost stressful situation where I know that my skills can be called upon in the face of adversity. Okay. All right. So what we've been talking about is leading up to these principles of what's called neuroplasticity. So again, I mentioned that group out of USC And this is one of my favorite papers. I try and read this as often as possible. It's such a great read, but they really go into what neuroplasticity is, okay? And the brain's ability to be, if we break down this word, it's the ability of the brain to be malleable, to be plastic, to change, to adapt, okay? And what we're learning is that when we have this motor learning component, when we have this skill-based learning component, this neuroplasticity is optimized, okay? So we're gonna go into a bit more detail into this neuroplasticity field. So as I mentioned, if you can imagine an environment where your demands have changed, depending on what that environment is, different areas of your brain can become engaged. So earlier in the talk, I said that within Parkinson's disease, about 50 to maybe almost 80% of the dopamine is depleted before any of those signs show up. Okay, so you can argue that the brain doesn't know that you have Parkinson's. It's adapted for years and functioned well enough without 50% of its dopamine. If that doesn't tell you the resilience and the adaptability and how active the brain can be, that's mind-blowing to me. Okay, so now what we're learning and what more research is coming into is that these cognitive domains, so again, those 5 cognitive domains are responsible or called upon rather from different areas, different regions of the brain. So this is a bit of a busy slide, but hey, the brain's a busy place, okay? So in that frontal lobe, again, these tasks of planning, problem solving, decision making, your motor cortex is there. That's all in the front. The parietal lobe, your sensation, your language, the occipital lobe, your vision, temporal lobe, language, auditory, memory, right? All those tasks are there. But now I'm going to change this. Oh, doggone it. Okay. So here, I think, I'm sorry, guys. So hopefully I can, this slide will pop up, but I want to tell you that here there's a lot of overlap. And what you can tell, what you can glean from this is that the different areas of the brain can talk to one another. There's different circuits, there's different pathways of communication. So depending on the demand, depending on the environment, different areas of the brain can work in concert. They can adapt. If other ones become saturated, if other areas are kind of overworked, a different area can compensate and become malleable and help you complete that task despite being damaged or despite being overworked, okay? So here, this is, again, out of that group from USC, they made this nice cartoon. It's kind of a recipe for that neuroplasticity optimization. So at the very top, we have this exercise, but it's not simply aerobic exercise. What they're finding that really sparks that neuroplasticity is that motor learning, right? So when we challenge ourselves, when we learn a new task, that brain health and those synapses, those are improved, those are strengthened, okay? Without going into getting a PhD in neuroscience, without going into too much detail on this stuff, that dopamine neurotransmitter is increased, okay? That's been shown in research. Those trophic factors, that BDNF, brain-derived neurotrophic factor, that's increased in the blood flow, okay? Those come up to the brain when it is kind of put in a situation where it's under high demand. So these cellular processes happen when the brain is faced with adversity, when it's like, oh man, I need to do something, I need to adapt, I need to work, I need to survive. These things happen in that difficult situation, okay? And finally, what we're learning is that this circuitry is enhanced. So as I kind of mentioned before, different areas of the brain that are responsible for your gait, your balance, your cognition, those can talk to one another. Those can be strengthened. Those signals, that circuitry can be strengthened when they're exercised. So when we have this, all of this kind of comes together, that can affect our behavior. That can make our motor movements better. That can make our cognition better. Okay. All right. So let's kind of take a little step back here and give you some direction. So we've gone over what skill-based learning is, skill-based exercises. Okay. So we know that it's a task is challenging when it's new, that is a skill. We know that motor learning is a type of skill-based learning, goal-based learning. Okay. So what are some examples? What can you do that will target those types of skills that will be that kind of motor learning? Well, we can do yoga, we can dance, we can do Tai Chi, we can box, okay? But it's not simply those kind of more aerobic exercise. This is not only aerobic, like boxing, you can certainly break a sweat. Same thing with yoga, dance, Tai Chi. However, you don't need to. You can also be cognitively engaged. You can learn a motor task by cooking, by learning a musical instrument, learning how to play a musical instrument, learning a foreign language, traveling. Again, you know, with COVID, that's a bit of a no-no at the moment. But think about how many different aspects of your brain are involved when you travel. Say if you go to Europe, you're walking over cobblestone streets. This is brand new for your visual spatial cognition. Where the heck am I? Okay. Not only are you having to maintain your gait and balance, perhaps you're having to use a different language. It's just so stimulating for every aspect of the brain that it's just it's the benefit. That's what we want. That's the level that's optimal. Okay. All right. We can do this as well with the power moves. Okay. You guys know this. I don't need to scream this at you guys, but power moves is certainly scalable. Okay. We can also do it with functional skills. Okay. I can certainly break things down and make things a bit more focused, learning the gait cycle. Okay. Parkinson's is a gait and balance disorder. If you're going to spend your time exercising, why would you be sitting on a bike? Okay. You need to be standing. You need to be working on your balance, moving through space. Make this engaging. Sitting on a bike, you're only working your legs, right? So if you think about, before you do any task, really try to think about how I can make this involved throughout my entire brain. And that's where the magic happens. That's where all the benefits of those neuroplastic benefits come into play. Okay, so as I mentioned, we can make this complex. We can do this in a different, we can do the same task of walking, but break it down, and all of a sudden it becomes a brand new task. Okay, so earlier in the week, I had an individual that I working with. We were going over sitting to standing. Okay, so if, yeah, okay, if I just tell you to sit to stand and not think anything of it, perhaps you can do that. But if I give you something else to focus on, so shifting your weight, reaching your arms out, bringing your nose over your toes, I'm adding those new novel kind of markers for you to attain to complete the task. Okay, so we kind of break down the procedure, and it, for the brain and the body, it's new, it's novel, and now all of a sudden it's this kind of, oh, I can, it's much more engaging. It has that motivational factor. You're intending, it's engaging those cognitive domains. I mean, guys, I hope you can tell that I'm getting excited here, that this stuff works. I can see it. I've seen it. You can get better with this stuff. All you have to do is challenge yourself. Okay, so let's keep on moving here because I'm blabbing on too much. An example of a very stimulating circumstance to be in the supermarket, right? What the heck am I doing? This is overload, okay? You might need to hold in your working memory, your shopping list. What aisle am I on? I need to use my visual spatial cognition and not bump the shopping cart into things. Okay. I'm using my postural muscles. I'm using my motor cortex. I'm using my basal ganglia to stand up tall, to move, to walk. Okay. If you really stop to think, this is a very engaging and demanding task. Okay. So let's go over some examples here. So this is one of my clients. I've been working with him for years. We have over 500 visits, over 500 hours that we've worked together. Now, this gentleman came in very high functioning, but we've pushed it even more. Okay, so that picture over here on the far left, he's running and jumping over things. Okay, this one in the picture, he's doing push-ups on 2 different kinds of balls. Okay, here, I'm not sure if you can see, but it's that Clock Yourself app, and then and I can talk about that a little bit more later. But within all of these pictures, there's so many different stimuli going on. There are so many things that he needs to focus on. Right now, he is not thinking about milkshakes and chocolate chip cookies. He is completely engaged, okay? And this is preserving his quality of life. This is making him better, pushing himself, okay? Let's keep going with some examples here. Now, this individual, in addition to having a super cool hat on, is walking over something that is squishy. So this is kind of working on your sensory feedback, some of that parietal area, so a different area of the brain. He's also working with some balance, right? He's got that narrow stance. He's walking on that squishy, unstable surface. He has some tactile feedback here with some of those walking sticks. This is very engaging throughout the entire brain, okay? Same thing here. I'm having him stand on 2 different surfaces. This is really confusing for the brain. Whoa, one foot is really squishy, one foot's really stable. Now I'm having him reach. This is something that is another motor task. So I'm having him reach. He's shifting his weight. Not only is he doing that, but he's doing it with a goal in mind. So I'm saying, oh, reach toward that orange 5. Or I could say, reach toward that anaranjado 5, okay? In Spanish, right? If something is too easy for someone, challenge them. Make it a little bit more difficult, okay? Finally, this is a kind of cool task that I've come up with. You can see on the bottom of the screen, there's those different colors, and you can step on that. Now, in the middle picture here, you can see this individual has a kind of an elastic band around her waist. So this will kind of yank her back and perturb her balance. Okay, so now not only is this a balance issue, but now she's got to step on these silly little colors. Okay, now what am I going to do? I'm going to make her step on them in a certain order. So now this is a cognitive exercise, in addition to a balance exercise, in addition to a lunge and stepping exercise. Okay, so for example, what I do with this one is I have the individual step on a particular color in a particular order. Now the rule is you would have to spell the word, or the color rather, in order, but just by one letter. So for example, in this picture, she's stepping on the yellow dot, okay? The first letter of the word yellow is Y. The first letter of the color purple is P. The first letter of the color blue is B. The first letter of the color green is G. Okay, so we have Y, P, B, and G. It's now her task to step on the color in alphabetical order. What? That is a very cognitively demanding exercise. She's having to hold in her working memory, which is a very executive frontal demand. What am I doing? What what letter am I on again? She's having to keep track of that. But she's also has the kind of back part, the basal ganglia of her brain is on because she's balancing, she's walking, okay? So if we can engage, if we can give examples, if we can give exercises that are engaging in multiple aspects, that's where all that neuroplasticity comes into play. So that's where all the magic happens. That's where all those benefits happen, okay? Just for the sake of time, I think I'm gonna have to run through, I had some videos, but maybe at the very end, I can go through and show those if we have time. So again, this is just my mission statement. If you haven't been able to tell, guys, I love this stuff. Like I just, this is the best to me. I want to shout this from the mountaintops. Every individual, Parkinson's or not, I want to be doing this type of exercise. I yell at my mom, I yell at my dad, you got to be doing something more engaging, okay? This stuff works. This makes your life better, okay? If you take nothing else from this, if you want a better life, do these exercises, okay? All right, so some resources. Again, use me. Like I said, I love this stuff. That's my email. That's my cell phone number. Call me, text me, fax me, come knocking on my door. I love to chat about this stuff, okay? I'm blabbing on again, yet again, but I love it. Use me, okay? In addition to that, I actually just heard that Brain HQ, unfortunately for individuals that live in California, there's a free app for individuals that are 55 or older. So I'm gonna have to look into that a bit more, but I'll certainly make an announcement about that. But that Brain HQ, I believe, is an app. It's certainly a website, but it was developed by a neuroscientist. So luminosity, doing Sudoku, reading, crosswords, it's okay. If you want to have cognitive engagement and you want an app, do this Brain HQ. In addition, this Clock Yourself app, it's something that I can show you on my phone if you guys really want, just for just for time purposes. I can show you later if we need to. I have a YouTube channel. You can certainly do that. And I don't want to speak out of place or speak for them, but I know everyone at the Power Gym loves this stuff too. So you guys can certainly pester them all you want with all those questions. And like I said, this is a big, gigantic component to the Parkinson's puzzle, is getting yourselves educated. So I'm so proud of you for kind of bearing with me and listening to me blab for an hour. But this stuff's important. You guys are empowered now. Like this, it brings me close to tears. This stuff is so attainable. You can have a better quality of life if you do these things, if you challenge yourself. Okay. So I think, yeah, so thank you guys so much, all of my clients, many of which are listening. Thank you very, very much. You give my life purpose. So thank you. The Power Gym, Dr. Giselle Petzinger, so she's the researcher, so she's a physician as well as a researcher up at USC that I mentioned several times throughout the presentation. Mike Studer, he's a fantastic physical therapist up in Oregon, I believe, and I've heard him speak several times on neuroplasticity. I've gotten a lot of stimulating ideas from him. And then of course my education at UC San Diego. A lot of you may know that's where I got my start, and I got to look over the shadow and work and learn from all these great people. Thank you guys very, very much. I believe that is all I had. Those are my references. So I'll go ahead and let's see, I can exit here and let me try. Okay, so I'm stopping sharing. Okay, so I can check that chat if there were any questions. Okay, that's okay. All right, so do I have any other questions? Yes, Sarah?
Yeah,
Yeah, I can hear you, yeah. If you don't
okay.
mind talking, then is that okay, Callie? If she talks, okay, cool.
Yeah, thank
Yes,
you.
sure, my
I
pleasure.
just have a question. You mentioned uh, the one where you walk, the machine where you just walk. What's the name of that? Where you walk, a treadmill.
Okay,
That it's good
sure.
to do a
Oh,
treadmill.
yes,
What
that
about
study.
elliptical? An elliptical, is that
Uh,
just as good?
Um, well, I would say not as good. So if you think about like an elliptical, so at least what I'm familiar with an elliptical is you have something to hold on to, and you're
Right,
kind of in these almost pedal-like um, uh, swinging kind of apparatus, right? So
right.
while you might be going through the motion, it takes an element of that balance and coordination away from walking that you would get on a treadmill.
Okay,
So
so
it's certainly better than nothing. But I would say I would argue that walking on a treadmill is
treadmill is better. Okay,
better.
that's good to
Of
know.
course, with safety. So I should have prefaced everything, but we want to make sure you're safe, obviously.
Right.
So yes.
Okay, that's good. Thank you.
Okay, sure, sure. Any other questions? I can try and see if anyone's
I'm Joe.
Joe.
Yes, hi,
Hey, Joe.
Mickey.
Hi, Joe. Yes,
Hi, Mickey. Thank you for the presentation.
my
I know you
pleasure.
had to get through it in a certain amount of time, and there's a lot more detail I'd like to know.
Right.
But some of the stuff is familiar, like you said, as having Parkinson's for a few years, you get to see these terms. What my story is last year when the COVID hit in March was the last time I did a power gym class until November. But during that time, I rode my bike and walked. That was pretty much the level of my exercise, plus the, uh, the Parkinson's exercises that I had received from Jennifer, one of the therapists at the power gym. I would use those and go through some of those. What I find now is that, and also before the COVID, we had circuits where we'd have stations set up where we do different functions. It's a little different than just doing aerobic exercise. And it really helped me. I noticed even though I was exercising during the summertime and into November before the power gym reopened, I could have gone on Zoom, but my computer, I didn't have that function.
Mhm.
So now I do. I bought a new computer recently, so I can do Zoom meetings. But now I go back to the power gym 3 days a week and do the class in person.
That's great.
I find very stimulating. And even though there's only maybe 2 or 3 of us, I find it to be a lot more fun and more social. So
Absolutely. Yeah,
my my
absolutely.
my concern is that we need to get back to some of the circuits we used to do and different stages that we set up at the old gym for people to do different besides cardio exercises
Mhm.
and stimulation like that. So
I agree.
um, the um, um, the gym does a good job with that stuff,
They sure do.
and
Yeah.
and we have a nice new gym now. If I don't know if you've been to Tucson to see it, but it's a lot better than the old one, and there's a lot more stuff to do. But we're kind of still in the COVID. We're getting back to normal, but it's going to take another couple months. I'm assuming.
You know, you're right. I certainly agree with everything that you said. I I I think everyone is getting anxious to get back to normal. You know, I kind of think we're at the end of the tunnel, or kind of see the light at the end of the tunnel, at least here in San Diego. We're able to hold small group classes, so no more than 3 to 4 people. But you know that's out here in California, so you know everyone's a little bit different, and I know we're all anxious to get back to normal life. But I certainly agree with you, uh, Joe, and thanks for letting us know that yeah, everyone's in that same boat. Yeah. Any other questions, guys? I think Evan, maybe? Yeah.
Yeah.
Hi, Evan.
Hi, you said there were two problems. One was the amount of dopamine, and the other was the dopamine circulating around your brain. So I take, a lot of dopamine supplements. So theoretically, that doesn't necessarily help if it doesn't get circulated around the brain. So does the exercise somehow help the dopamine circulate around the brain?
Right. Yeah. So yes. So it's kind of a, I don't want to overstep my bounds and speak out of my lane. But in theory, when individuals take that dopamine replacement pill, a prescription medication, there's only a relatively small percentage of that actually getting into the system. So passing that kind of blood-brain barrier is an issue with the type of medication, just by nature of the dopamine molecule. So yes, that the pharmacological issue is that many smart people are aware of that, and they're constantly trying to work on different types of the medication, getting it into the brain in different ways. And those are something that you can certainly talk more about with your doctor. But to kind of tag on to the second part of your question, dopamine is really involved in all sorts of different aspects of life. One of which is that kind of smoothness of movement, but it also helps enhance that circuitry. So it enhances the signals pretty much throughout the brain, and it helps those connections move more efficiently. And it's really kind of, I've heard it referred to as almost kind of like miracle grow. So it's something that just enhances, it makes everything better. It helps everything communicate better. Yeah. So hopefully that answers your question.
Yeah, oh yeah, thanks.
Mm-hmm. Let's see. Yeah, Doris. And I think, let me have you unmute. Can you unmute yourself?
Hi,
Oh,
Mickey.
hi.
It's Ellie.
Oh, hi, Ellie.
How are you?
I'm
I don't
good,
know why
thanks.
my
How are
name
you?
is Doris here.
I don't
for
know
some-
why either.
That's so weird.
I
My
thought that
brother's
was
here
you,
too.
but
Hi,
anyway.
hi,
Hi.
hi, Jim. Hi, Jim. Jim is here. I don't know if he can hear. Anyway, I was going to ask you about the apps that you mentioned.
Oh, sure. Yes, yeah. So I can show you. Yeah. So unfortunately, it's kind of lackadaisical here, but I'll show you on my phone. So this is
Okay.
just that Clock Yourself app,
Okay.
like that. So that's the logo. You can go into your app store, and I believe, for me at least, I think it was like $2 or something like that. But you can see, I'll move my phone up here, so you can have different components. So you can just do it with colors. You can do it just, I think that's a simple clock. And just like I mentioned in the presentation, you can scale up here. So this
Okay.
can be made more and more difficult, more challenging, adding more components. Okay.
Maybe you can show it to me next time, actually,
Sure.
in class. Yeah.
Yeah, absolutely. I can do that. And I'll just put this up here. So this is just kind of one of the more basic ones, but you can see,
Oh, I see that.
there's kind of those 2 feet, those 2 footprints there in the center. And ideally, we want you to step on those numbers that are kind of in space there.
Right, right.
Yeah. So actually, I have this here. So this is something that we use in class all the time, right?
That's
So
true.
same principle behind that. So you're kind of stepping on the different
Right.
colors or different
Mhm.
number and things like that.
Yeah, another thing that I kind of noticed with my doctor, neurologist, every time I go there, and he asked me to like do the months, like from December back, and then I get stuck for some reason. I go like December, and then I get stuck in like July or something. Why?
Right. Why is that? Yeah, so I mean, well, first it's difficult. Like I think it's difficult for anyone. But that is one of those tasks that I'm not sure if you saw it earlier in the presentation, but that's one of those areas of your cognition that's in that frontal area.
Mm.
And it's something that is characteristically, or it can, not saying that it will, but it can be common in Parkinson's. So due to the disease state, there can be some dysfunction there, but it is
Right.
one of those areas that can be improved, right? So if you and I, if we work on some kind of working memory exercises, I wholeheartedly believe that that sort of skill can be applied to
Right.
in that situation. Good question.
Yeah, thank you.
Sure.
I think my question's related to that. Like
Sure.
when I have, I had the basic power. I go to the gym regularly. I've been going maybe 4 years, 5 years. And people started adding these more complicated functions, and I can't do them. Like if I can't make my left foot go one way and my right arm go another way. And if I should just keep repeating it and you think it will come in time?
So that brings up another good point, right? So it's kind of a diminishing returns kind of issue, right? We don't want to give you something that is too far of a reach. That doesn't feel good to anyone when they can't do something, and that has kind of all these negative implications. So what we can do and what you can strive to do is find something, ask one of the instructors there at the gym to help you find something that is attainable, yet challenging, but not too far out of reach, right? I'm not asking anyone to be doing handstands, right? I'm not asking anyone to be running marathons, okay? But it's kind of this finding and establishing that baseline, and then finding something that is challenging to you that is still attainable with safety. So hopefully that answers your question. So I wouldn't keep doing it if I were you. I wouldn't keep failing. I would try to modify it in a little bit of a different way, so you can learn and eventually get there. So take a little baby step back.
That's helpful.
Good. All right, gang. Any other questions, concerns? Oh, I think I see a hand up for Kathy there. And yes, sir. All right.
I'm with Kathy. I'm Norm.
Hi, Norm.
And my better half is with me. But I go hiking most every day of the week with my hiking partner who's got Parkinson's. And we do about 1.7 miles. And the question is, sometimes we're on and sometimes we're off. And you have to push yourself when you're off. Is it better? What's the best way to go about this? To wait for yourself to be on and to try and gain from that? You can be safer and use poles. I always have poles with me when I'm off, but I don't always use them, especially when I'm on. I'll just carry them and use them only in a difficult area. How do you rate that kind of exercise?
So
in terms of being off or on?
Okay, so the on-off, that's kind of that phenomenon that occurs in Parkinson's, and it has to do with the medication. So depending on the medication, it can kind of have these ebbs and flows of how you're operating or how much dopamine is in your system and how well you're functioning. So on, you're good; off, you're not so good, right? when any kind of exercise you do, in my book, you want to be optimal. So be on. So that would be my recommendation, is to try to go hiking when you're on, when you're at your best, because when you're suboptimal, when you're not at your best, you're not achieving those same benefits that you could have had you been operating at your best. You're not pushing yourself to your fullest limits if you're being held back by just because the medications are wearing off.
The problem is we're in Arizona. And if you want to go hiking, as it gets into June and July, either you're going at 6:30 in the morning, and you may be on, you may not be on.
Right.
But
Yeah.
I feel like I've got the appointment set with my partner, so I'm going to be there. Maybe we'll do less of a hike.
So yeah, you can certainly modify in that way. That's a good modification, is to just do something a little bit less challenging, less dangerous, when you're not feeling as well as you could be. I will, however, maybe gear your question so you could ask your doctor. So if you could take, I'm not a doctor, but I've heard that some people might take just a little pill, a small amount, before they go exercise. Just kind of a little bump, if you will, to kind of get you there. But again, speak to your doctor about that, because you want to be as optimal as you can when you do these exercises. When you spend the time, when you devote the time to exercise, you want to try to squeeze everything you can out of it. And you're kind of cutting yourself short if you're not optimally medicated. So that's not to say just, walking on flat grass while you're kind of wearing off isn't beneficial. That's certainly better than doing nothing. So hopefully that answers your question.
Yes, thank you.
Of course. All right, gang. Let's see. Any other questions, concerns? Maybe not, huh? Okay. Well, like I said, guys, or any other questions? Yeah. Okay, good. So yeah, like I said, this is something I obviously feel very passionate about. Hopefully you learned something. Hopefully I answered all your questions. Do not hesitate to contact me, okay? Like, I live for this stuff. Day or night, come knocking on my door, call me, text me, fax me, email me, whatever you want, okay? All
Can I
right.
ask you something?
Oh, sure. Yes, Ellie.
Nikki, someone asked about the supplements, dopamine supplements. What are those? Is that the medication that you're taking?
I would assume so.
Someone asked about, I thought like it's another, like a different supplement that they have to buy from the over the counter. That's not, they don't sell it, right?
Not that I know of.
Okay, it's just the Cenemet or Rytary, right? That I'm taking Rytary right now.
Right. Yeah. So those are like the prescription medications.
Prescription medication. Okay.
Right. Yeah. So like the over the
difference
counter.
though, by any chance, do you know the difference? Anyone knows the difference?
I'm not too familiar with any dopamine supplement.
I mean, you mean the
there
medication?
is one.
Oh, okay. Yeah, Callie. So
Yeah, so there's one called MOCA. So it's like a natural form of dopamine, but I would definitely speak to your neurologist or your movement disorder specialist before trying to add that to your regimen, especially if you're already taking
Rytary.
yeah, Raitari or Cinemet or anything like that. But there is something called MOCA, which is
Lacuna.
what you're probably thinking of. Yes.
That I can buy over the counter. Is that what? Okay.
Yeah, it would just be like going into like any Walgreens or CVS where they have all their supplements.
Okay, I have to just check with my neurologist first.
Yeah, yeah, absolutely. Before, taking any sort of kind of foreign substance like that you don't
Sure.
find in food, I would definitely recommend speaking with
Yeah.
your neurologist, especially if it's going to interfere with Raitari.
You are MD, right?
No, I am not. I'm a
Oh.
physical therapist.
Physical therapy. Okay.
Yeah.
Thank you so much.
Yeah, of course. No problem.
All right, gang. What do we think? Any other questions, concerns?
Very good. Educational. Thank you.
Great.
Thank you.
Good call.
Thank you. Thank you.
Well,
Okay.
Thank you
Thanks,
so
Mickey.
much, Mickey. Thank you so much. And I did want to mention, just for anyone who does come to the Power Gym, I also have the Clock Yourself app and love it. So if you want to see it before you pay like the $2 or whatever it is for it, try to snag me and I can show it to you on my phone. But yeah, thank you, Mickey, so much. That
My
was
pleasure, guys. Yeah.
absolutely
It's so
wonderful.
nice
you.
to see the familiar faces. Russell, hey, how are you? I remember you.
Very
Nice
good to see you. I hope you got
Yeah.
another retreat.
I know, gosh, let's try and get another one of these, huh?
Nikki,
All
can
right.
you share
Yeah,
your
fingers
That was
slides?
great.
Did someone ask a question? Sorry.
It's asking if you could share your slides.
So it is going to be recorded. So I recorded it. It's going to go onto our website. So if you are a virtual or in-person Power Gym member, you'll have access to it there.
Okay, great.
Yeah. Yeah. Perfect.
Thank you.
Yeah.
All right, guys.
Sounds
All
good.
right.
Thank you
One
guys
last
very,
big
very
thank you to
much.
Mickey. Thank you.
Thank
Thank you,
you.
guys.
Thank
Thank you,
you.
Callie. This
Thank
was
you.
great. Appreciate it.
Thank you.
All right. So we're
Thank you
good to
so
go.
much.
Thank you.
Bye-bye.
Okay. All
Thank
right.
you so
Thanks a lot,
much.
guys.
Thank
Bye-bye.
you.
Thank
Thanks,
you.
Becky.
You're welcome. Bye-bye.
Bye.
Bye-bye.
Bye.